This video is going to be about reference angles. So reference angles are used a lot when you are evaluating trig functions of any angle. But this video is just specifically about how to find a reference angle, what is a reference angle, how to locate it, that kind of thing. So shouldn't be too long. So what is a reference angle? So a reference angle is an acute angle formed between the terminal side and the x-axis. Alright, so let's break this down. First, let's just pick an angle. I don't know, let's go 100 degrees. So 100 degrees is our angle. So let's graph it. So we would graph 100 degrees by drawing the initial side. And then it would be in the second quadrant. And there it is. That's 100 degrees. Okay? So an acute angle means an angle in between 0, right? Theta has to be in between 0 and 90. So your reference angle has to be something in between 0 and 90. And a lot of people will give different notation for the reference angle. Like I've seen textbooks use theta prime. I've seen people use theta with a line over it like this. It just depends on the problem that you're working on, the textbook, whoever wrote it. So either way, a reference angle could be something like theta prime or theta with that line over it, or they may just say reference angle. But either way, it's going to have to be in between 0 and 90. So it's a smaller angle, it's an acute angle, and then it says formed between the terminal side and the x-axis. So let's locate the terminal side. That would be this guy right here. This is the terminal side, and the x-axis is going to be right there. Hopefully you can see that. The x-axis would be this. So we're actually just looking for this angle right here. That's theta prime. Okay, so if you do some quick math, two angles that add up to 180 would have to be, one of them being 100, the other one would have to be 80. So in this case, theta prime would equal 80 degrees. All right, so reference angle is just an acute angle formed between the terminal side and the x-axis. You may be asking yourself this question, Mr. Yasuda, can I use the y-axis? Right? Could I use the terminal side and the y-axis? And then in this case, it would have been 10 degrees. Does that matter? The answer is yes, it does. And no, you cannot use the y-axis. So don't ever use the y-axis. Only use the x-axis when trying to find the terminal side or the reference angle. Okay? All right, so let's just practice a little bit and then we'll be done. So we're going to start in degrees. So find the reference angle for each angle. So first thing I encourage students to do is I say draw the angle. It doesn't have to be beautiful, but you're going to need to know like what quadrant it's in so you can help yourself do some math, right? So here we go, initial side, and 175 degrees would be in the second quadrant. So there is 175 degrees. So if you notice now, you're usually going to be adding or subtracting, from some of these quadrant angles, either 180 or 360, because those are where the x-axis is. And so in this case, it would make sense because you're trying to find theta prime right here. If you can't tell what it is and you would like some mathematical expression to do, you know that all the way halfway is 180 degrees. So we can do 180 degrees minus 175 degrees, and that would be theta prime. So that would be 5 degrees. Okay? If you want to pause the video and try 271 on your own, feel free, and then I will do the answer, and you can see if you were right. So 271. Here's my initial side. Okay. And then 271 degrees would be in the fourth quadrant, right? just somewhere right there, probably even closer to the y-axis, but either way, it doesn't have to be perfect, it just has to be in the right quadrant. Now, the tendency for some students is to go back to the y-axis, but you heard me make a big deal about it. Don't go to the y-axis. It's always the acute angle between the x-axis and the terminal side. And so right here would be theta prime. So I would actually want to do 360 minus 271. And 360 minus 271 would be 89 degrees. Whoops. I'll learn how to use my stylus. 89 degrees. And there we go. All right, so those would be our reference angles. Now you say, what are reference angles used for? I've got a video on that. You can click on that at the end of this video. But we use them to evaluate trig functions like sine, cosine, and tangent of 271 degrees or 175 degrees. Probably not those specifically, but that's what we use reference angles for, and a handful of other things. All right, so let's try it in radians. You might find that you like radians better than degrees, but nonetheless, here we go. My tip still doesn't go away. Draw the angle. Right, so 4 pi thirds. 4 pi thirds. Well, halfway around is how much? Halfway around is pi. And 4 pi thirds is bigger than 1. So we're probably in the third quadrant. And so this is 4 pi thirds. Now if you ask yourself, okay, acute angle between, right, the x-axis and the terminal side, that means we're looking for this angle right here. So if pi is 3/3, well, you went 1/3 more, so theta prime equals pi thirds. Right. The nice thing about reference angles when they're in radians is that the denominators will always be the same as the original angle, because in essence you're always subtracting. All right, I'm doing 4 pi thirds minus pi, and so I'd have to have a common denominator. So that becomes rather helpful in finding reference angles. All right, let's draw -9 pi fifths. If you want to stop the video and draw it yourself and then try to find the reference angle, that'd be great. And then you can hit play and you'll see me finish the problem. All right. Here's my initial side. Negative means I'm going this way, so that would be 5/5, right? And then 9/5 means I'm almost at 2, but I'm not quite there. So that would be -9 pi fifths, and this would be my reference angle right here, theta prime. And so I'm almost trying to get to 2 pi, which would just be pi fifths. And your reference angle, once again, remember, I don't need the approximation symbols. Your reference angle is going to be always positive, so pi fifths. All right, and that's how you find reference angles. Hopefully that's helpful. Feel free to click on the video above in order to see how we use reference angles in order to evaluate trig functions. So have a great day. Talk to you soon. Bye.